So we all know what the weather is right now because we mostly just came from outside and we just looked up the Canada weather. But do we know what the weather is going to be tomorrow at, say, noon? No? Okay. Well, meteorologists have a pretty decent idea of what the weather is going to look like right here in College Station tomorrow at noon because of a technology called Doppler radar. So, howdy, my name is Trinity Boudreau. I'm a geoscience major at Texas A&M, and I've done research on Doppler radar technology. So, first we're going to go over, today I'll discuss how Doppler radar works, why it's effective for studying weather, and further applications beyond discussing weather. So Doppler radar is a system of using radio waves to look at an object or to find the range of a target from where you are. So if I'm standing right here and there's a cloud right there, I want to know how far away that cloud is. In order to do that, they send out radio waves at the predicted area of the target, and however long that light wave takes to come back determines the range. So as you can see here, these Doppler domes will send out a radio wave, and it will either come right back or it will hit the ground and reflect back and create an echo effect that is helpful for knowing where it is specifically in the atmosphere from like a vertical and horizontal approach. So my analogy for this is using a boomerang. So a boomerang you throw a boomerang, but it will come back to you. So say you had a balloon and you let it go, you toss the boomerang and it taps the balloon, but it still comes back, even though it hit the balloon. And the amount of time it takes to come back from the balloon is roughly the range of that balloon. Radar stands for radio detection ranging, and this was studied by Clive Alabaster for his study of Doppler pulsing. Doppler pulsing is how we're able to track a cloud's movement. So we'll send out one set of radio waves, and that'll be the cloud at 12 a.m. But then we'll send another wave out, and that'll be the position of the cloud at 2 a.m. And if it's a fast-moving cloud, the position will change, and we'll be able to track it.
You're okay. You're good.
So, reasons why this is effective. Doppler tracking is effective because as we send out the pulses, we're able to track where the storm is moving. And you can't always see what's moving the storm, so maybe it's wind currents, maybe it's air pressure, but with Doppler radar, we are able to track specifically where and what is moving the storm. And this is according to Sue Mann in 2021. And another thing is, we're able to more closely understand what is within a storm. So some storms can have just regular rain, some can have freezing rain, some can have snow, some can have hail, but we don't always know this just from looking at the clouds or studying the weather patterns. So Doppler is able to help us track storms, and the closer they get, the more accurate the Doppler maps are. So 2 weeks from a storm, it'll be just some change in the wind patterns and small clouds. 2 days before the storm, it'll be more like this. You'll be able to see the rotations, the different, some can show amounts of lightning and things like that. And this is according to Lee in 2021 when they did a study in Finland looking at different ice particles over the Finland countryside during winter. So my analogy for this is driving a car at night. So you're not able to see the road unless you have your headlights on, but because you have your headlights on and they're like spread out to where you can see the road, you'll know if there's something like standing in the road, if there's like another car in the vicinity. You'll be able to see things even though you're not aware of them before that point. And you'll also be able to see, or this is helpful for whenever there's a severe weather situation. So further applications for Doppler radar. First we have the military use for it. So they will use sonar buoys that are just spread out across the water, and when a ship is passing by, they're able to look at the waves that are sent and received from the sonar buoy. So when a submarine passes under the sonar will record that and send it to the ships that are passing by. And another one is for medical use. Oh, the military one was by James in 2006. The medical ultrasound is another version of Doppler use. Is able to track clot velocity. So if you have some kind of heart condition that causes clots, they don't have to open you up to figure it out, because that could also weaken your heart. So they can do non-invasive surgeries faster, and this is according to University of Michigan and NCBI, both in 2020. So today I talked about why Doppler gives us insight about space around us, whether it's things you can't see within yourself or things you can't see in the sky. It allows us to track targets, and this is why it is effective for weather and military and medical use. And those are all of Doppler's applications. And with this insight, hopefully you will pack an umbrella tomorrow. Thank you.